What happened? Someone set up us the bug. We get signal. What? Main screen turn on. It's you.
How are you, gentlemen? All your base are belong to us. You are on the way to destruction.
What you say?
You have no chance to survive, mate. Your time. Ha ha ha.
And thus, one of the early internet memes was born. All your base are belong to us. That was like right up there with Dramatic Gopher and Star Wars Kid and Charlie, you bit my finger. Okay, so we're going to talk about the Arrhenius way. The Arrhenius way of explaining how acids works. This is mostly workable with very simple acids, but it falls apart with more difficult acids. So unfortunately, the Arrhenius way, the Arrhenius method has been modified. So what I'm going to go through works, but it also doesn't work. It's not correct, but it is taught in school because it's so simple and it explains mostly how acids work. Basically, the Arrhenius way says that acids will ionize to form a hydrogen ion, and bases will dissociate, right? Because dissociate. Lost my train of thought here. Instead of my shadow. Bases will dissociate to hydroxide. And we kind of talked about this. So, for example, HCl will break up into hydrogen and chloride ions. It kind of explains why acids have hydrogen, is they give up a hydrogen. They didn't necessarily give up a hydrogen, but they form hydrogens. Something like HSO4 will break up and lose a hydrogen. So, great. And then bases, something like sodium hydroxide, check your solubility table. What the heck? Bases will form sodium and hydroxide ions. So you can see the Arrhenius method keeps things very simple. It makes hydrogen ions and it makes hydroxide ions. Now, that's all well and good for most acids and most bases. The problem is, what about ammonia? Ammonia is a very strong, it's not a strong base like hydroxide, but it is a fairly powerful base. So, if bases make hydroxide, how does this even work? Well, that was one of the biggest limitations of the Arrhenius method, is that some substances, some substances had acid and base properties. But, well, did it work with the Arrhenius method? Arrhenius. So, ammonia is a good example. Other things like sulfur dioxide have acidic properties. And how do you even... WTF, right? So there had to be a different way to explain how acids and bases work. And we're still gathering, as scientists all around the world, a framework to explain this. Arrhenius is such a small part. We introduce it because in Chem 30, we cheat a bit and we use a little bit of Arrhenius in chemistry to help explain simple systems. But the correct way is Bronsted-Lowry. Bronsted-Lowry gives us a better understanding. There were two separate scientists who came to the realization that you had to do a better job of explaining what happens with acids and bases. And what they found was that acids give up a proton to water. Acids donate hydrogens. Now, with very simple acids, we're just going to do simple and medium difficult ones today. With very simple acids, it just takes a little bit different way of looking at it. It's not that the acid is in water, it's that the acid reacts with water. And acids give up their hydrogen to the water. Now, if you give away a hydrogen, hydrogens are positive, so that will leave a negative ion. You could use slidey finger, it still works here. And you would get a weird molecule called H3O positive. This is called hydronium. Not hydroxide, but hydronium. Hydronium is the molecule that gives things their acidic properties. And it was just a little bit of a shift to explain why it works this way. Now, very simple base reactions work with Bronsted-Lowry, but you're going to get really annoyed very quickly with them, and I'll show you why you're going to get so annoyed. Some of you will see what's happening as I go. Okay, so bases usually have a metal attached, and the first step is you have to break up the metal. So the metal gets the boot. That's actually a big step in Chem 30, is removing metals from basic ions. The second step is that if acids give away a hydrogen, bases take a hydrogen. Or we call it a proton. And they take the proton from water itself. Now, here's where things are going to get very annoying. It's going to get tougher than this. But if hydroxide takes a hydrogen from water, what does that make hydroxide when it gains extra hydrogen? Well, if you gain extra hydrogen and you're OH, you become H2O. And if you're H2O and you lose a hydrogen, you become hydroxide. So yes, this reaction is very silly. But in very simple systems where you have hydroxide, the hydroxide does rip hydrogen away from water. So the moral of the story is that acids donate hydrogens. Okay? They're proton donors. Bases take hydrogen. And where do they take hydrogens from? Or where do they give hydrogens to? Water. Acids give, bases take. Now, how does this help explain ammonia? This is the cool part. Okay, we're just going to stop after this slide. Ammonia is a base. What do bases do? Bases take hydrogens. So if we have water, the ammonia takes a hydrogen from water, and because hydrogen's positive, what do you make? Oh my goodness, it's ammonium. You guys know that exists. And if water loses a hydrogen, you get hydroxide. And this was the giant light bulb, curly Q, that happened in chemistry to help to explain some very difficult acids and bases. This doesn't have hydroxide in it, as Arrhenius would explain what a base does. It makes hydroxide by ripping apart the water. Okay. Actually, I lied. We're going to do one more slide. So we're just going to do this one. So let's say we had sodium dihydrogen phosphate, and you were trying to write out the reaction between it and water. So the first thing is we have to write out what sodium dihydrogen phosphate looks like. Okay. Now, the first step is we have to break it apart. The metal gets broken apart. So we get sodium and dihydrogen phosphate. Okay. So remember how we said we get rid of metals? Now, there's a shortcut. You can just, if you are really good at seeing what this looks like in your head, you could just jump right to the second step. Or you can write this out and cross off the sodium, but remember that now you have a negative charge because that's an ion. This substance is now going to react with water. So this question also gives us evidence. What is dihydrogen phosphate acting as? Well, it says the litmus turns red. What turns litmus red? Acids. What do acids do with their hydrogens? They donate them. So the hydrogen from there goes to the water, and now this loses a hydrogen. It's now down a hydrogen. And this becomes H3O positive. Now, what do you think the charge of this substance is? You can look it up. It's hydrogen phosphate. It's in your polyatomic table. Or, as you lose a hydrogen, this now is 2 negative. It's 1 more negative than it was before. Okay. So I'm going to stop the lesson there, and we'll pick this up again on Monday. You guys are going to have a couple little Google things to go through that goes over how to test this. Okay?